Hey, hello everybody, this is IA, and today you've seen it in the title of this video. I went back to my 8-bit computer IAPC8. It has a little bit changed from last time. As you can see, the ALU here was there before in that direction, but I figured out that there was current problems when electricity came towards the end and came back. The chunks were not actually properly loaded, so I made a little bit of movement here, but the principle is the same. I did not change anything to this. I'm sorry this video came pretty long time after the first video I made, the presentation, but the reasons are that I lost the map actually, and I restored my data, and I was not really motivated to make things with it. I wanted to make videos to explain a bit principles, not in details, but principles of each unit and why it is pretty useful for anyone to know or to see how complex things can be done with just wires and torches, so reversers. That's pretty cool, I think. It can be useful in various ways. Basically, if you're seeing this as just a computer, here it is just a machine that makes computations such as multiplications, integer multiplications, um, additions, subtractions, and shifts, storing data and getting data back, printing out on screen. So it is not that powerful. You don't have lots of memory. In this model here, I have added this memory bank here of 2 times 8 bytes here up there, but I did not connect it yet, this second unit. So that's just one block here floating in space. But the thing in that computer, you might have seen computers in Minecraft, other 8-bit computers that works with quad-core CPUs, with large graphics, with high speed, with accelerated servers, and contraptions like that makes the thing really fast. And that's not actually the main goal of that computer. So I made this computer to be understandable. It was for me first. You see there are a lot of space here which is not used. Things are spaced. Everything is visible, and I did not try to make the things as small as possible, but the most explorable as possible. So even data here, which can look like a bit messy at first sight, is quite spaced actually. You have repetitive patterns, but you can walk through and see here is the input part for a bit, and bit value is stored here. Here's the RS. You have 2 reverters here, and then you go back to the second one with input zone here, reverter here, and then output here. So things is pretty simple to visualize. I did not execute a lot of stuff with this. This is more an exploration project, and I did not use it a lot. Even I just loaded the map and saying, yeah, I will explain a bit how this works, the main principles of this computer, and how it can be interesting for people to look at it and to learn about this. But I don't really remember actually each wire, the role of each wire and each connection. But because I made it in order to be understood, in order to be clear and to, yeah, for me to remember how this works without having to write things on external papers. Just by looking at the wires, I can guess, oh, this is the ALU operator here. Yes, yes it is. This is the ALU operator here for comparisons here, because we only have equal hierarchical gates for equality, and these are operations for comparison. We have plenty of operations that can be connected to those wires here. We have multiplications, additions, and I can easily find my way through this because it is clear, and that's not real fast, but I don't really care actually. So this computer is a project that cost me 1 year, 1 full year, but the biggest part of this was not to build it, even if I use softwares such as MC Edit or Word Edit, things like that, which I did not really use that much actually. But the biggest thing with this was to create and invent something that together works with kind of instruction of hardware instructions and a panel here to communicate, to say do one thing with one unit, connect one unit to another one, and transfer one value to somewhere else. And this was very interesting. And basically, when everything is planned and you have an idea of what you want to do, actually, computer is quite simple at the end. It's not really complex. The complexity came from, I want to do a machine that makes my stuff, so I must do the units first, connect them, and do an interface to for my instruction to call, and things just work because your computer is correctly connected. Sorry. So that was a pretty long introduction. Sorry for that. This video won't be that long. I'll just show you the different units just quickly, and maybe in future videos I'll cover some mechanism in data, for example, for screen, which I think is pretty interesting, with the ALU and maybe the CU, but I don't really know if it's really important. Let's cover this. First, our computer here works by an impulse here, a pulse here. It came from this power on lever, which generates a pulse here. And when this pulse is generated, you have a signal going through that wire and rolling here every, I don't know how many ticks I made, but this is releasing in this torch as impulse, as different pulses, and each pulse will allow the whole program zone to be executed. Here you have gates, which are binary selectors, so that only the execution we're targeting will have a pulse getting over this, like this. Actually, this is not just 1 plus 1 plus 1 plus 1. It's the value of your current instruction is stored in a register here, and this value is given here, and depending on the value we're selecting one instruction to run, so we can run an instruction and run it again, etc. We can go that way and go back, etc. So this allows me to make the transition. Here is the PCO unit, which is program counter operation unit. You've got a register here, where is it? registers, your input for registers, your are additioners. Where are the registers? Here. So we get 1 bit here, second bit here, 3, 4, 5, 6, 7, and 8 bit here. So you got a register here for operand counter, an adder, and a +1 operator here, which computes basic instruction increase. Or the adder can be used for getting back or getting a specific position. So this is a bit simple. Actually, the only complicated thing here is that there's delay because we're getting a value and writing back to the register without storing it somewhere and then the other taking it. So yeah, quite tricky on delay here. We have the data unit there. As I told you, I made another copy up here. I don't remember if I told it, but yeah, this is another data unit here. This is a copy of this one, but not connected yet. So here is our data, basically connected to our computer, and we got a unit, not a unit, but a connection zone here, so we can address to target 1 byte, and we can say I want to get the data from that byte or set from input from the value that I given as input, and we can connect theoretically to 256 bytes of data with this computer, but I only have 16 here and 16 more with the upper unit. So this is maybe the simpler unit, the whole computer maybe, I don't really know, but yeah, something like that. Up here we got the ALU, which is the arithmetic and logical unit that basically do arithmetic operations. This is a larger unit because it has a lot of uses. We can add, we can have additions, multiplications, +1 operation, and shifts here, left shift, right shift. So this is a bit big, but not that complicated actually. Takes place, but not complexity. Here is comparison, so two values know if they are equal or not, and the values are written in a register, an output register somewhere here, and we can use it in our computer to write it into data or do something else with it. And in the center of this unit, all these units, you have the CUU, which is basically all the connections between the data, between the ALU, between the screen, which can be considered as a unit as well, between the PCO and program. We got the CUU, which is this interface here, which significates all you can do with your computer can be given to those sponges and ice blocks. The lights here are just information getting back from the computer to the user, but I don't actually need it. I made it so it can be useful somewhere. I'm not using it currently, so just communicating with sponges and ice blocks, with packet ice blocks, will make the computer make the operations you want. The CUU is basically just connections, so wires are connected to units. You're calling to one unit or another using this interface, and you're making like bridges between, for example, data and CUU, data and ALU there, or between data and a PCO, things like that. All the bridges, all the connections are made by the CUU, which is the basic connections, all here and up there. So this is basically just connections. CU means computer to user interface, by the way. So user can be considered as the program here. We just put blocks there in this interface, and the computer will make things. So that's basically it. We have a screen here, and the thing is that communicating with the CU, we have somewhere the CU in. Basically, we are writing, for some reason, we're writing into the CU out. So as user input into the output of the CU here, and then the CU can answer back a reply to CU in, which is here, and this can be used to directly connect to the screen. Yeah, that's basically it. In further videos, I'll explain a bit how the screen work and how the screen, the PCO, or things like that would work. And I'll not be that longer on this video. So thanks for watching. Sorry, and yeah, that's it. I don't know how to finish videos as usual. So thanks for watching. That was IA. Let's code.